All right, so let's talk about probability sampling designs. So when you're talking about probability sampling, basically you're talking about the way that you pick a sample in such a way that you can address that generalizability that we talked about, the degree to which the sample will be representative, and the degree to which the characteristics of the sample, so the race, gender, income, personalities, will be the same or as close to the same as possible from the population you're getting that sample from. So in order to do that, there's one basic principle, and that's the fact that everybody has to have an equal chance of being selected. That's critical. Every single person in that population should have an equal chance of being selected. So if there are 100 people, and you want to get a sample of 10 out of that population of 100, then everybody has 1/10 or 10% probability of getting selected. That becomes really important in statistics, but for the purposes of this class, it's that you just need to remember that everybody has an equal chance, with the caveat that it's never going to be perfect. You're never going to be exactly the same. There's always going to be a little bit of sampling error, but that's where statistics comes to the rescue. Statistics can adjust for that sampling error so that you have a better chance of adjusting for the results and making sure that that can generalize back to the population. So some definitions to keep in mind when you're talking about probability sampling. Your element is the unit of study. So are you looking at people? Are you looking at families? Are you looking at communities? Are you looking at houses? Are you looking at census blocks? Are you looking at cities? So the element is, what are you comparing? What are you analyzing? The population is all of those study elements put together. And then the study population is those from which your sample will actually be selected, okay? So overgeneralization is a bias that can occur when that sampling frame isn't consistent. So again, think of the example of drawing numbers from a list of home phones. If you try to generalize that for people that don't have home phones, the results of a study about substance abuse may not apply. There might be some inherent differences in people that have a house phone. Maybe they're older than people that only have cell phones. So you can't overgeneralize. And then there might be people that just choose not to participate. If you send mail to 100 people and ask them to participate in a survey with a sealed envelope, guess what? The people that respond are all going to be the people from which you get your data. So maybe the people that don't respond are people that are busier, or maybe they have different opinions, or maybe they're younger, or maybe men tend to check the mail and women don't. So there's all these different issues that can come depending on who gets included or excluded from a probability sample. There's also different types of biases like culture. Maybe you're trying to assume that something means one thing in one culture and another. If you do a study with white middle-class college students, can you assume that that same information is going to apply to middle-aged immigrant women? And of course, gender bias. If you're only including men in your study, you can't assume that women or people who are transgender will also have the same perspectives. So there are 4 different types of design. We'll go through each one. Simple random sampling is the simplest. It basically means everybody gets a number. There are special tables of random numbers that are included in most statistical textbooks, and you just use that to select elements for your sample. It is time intensive, but it is the most fundamental. Systematic is usually the every kth element. So this might be, I want to pick in a classroom every 10th person, or I want to pick in a movie theater every 3rd person sitting somewhere. The difference here is it's the sampling interval. So your interval is whatever, it's the 5th person, the 6th person, the 10th house, the 20th city. The difference in why you might use this versus the other one before, the simple random, maybe you intentionally want to keep people that are next to each other. Maybe you do a study, simple random sampling, there is a possibility you could get 2 people that live right next to each other, but maybe you intentionally want to spread it out, so this could address that issue so you never get 2 people back to back, assuming that you've got people listed in order of the proximity of how closely they live together. And this is just a depiction of what that would look like. If you have 100 people and you want 20, you might just start with start with number 4. So if you start here and you count from 1 through 5, you take every 5th unit. So 1, 2, 3, 4, 5, you include them. 1, 2, 3, 4, 5, you include them. So pretty simple and straightforward. And then that results a sample of 20 that's been selected through systematic random sampling.